power system industry to present on work that they've completed to a panel of industry experts. So I hope everyone on the event finds the presentations and the event both informative and entertaining. So to give everyone an idea of the agenda for today's event, we will initially talk about what CIGRE is, the role of CIGRE in the power system industry, and also an introduction to the judging panel. We will then have our first 4 presentations, followed by a quick 5-minute break, followed by our first of our 2 guest speakers of the day. Conor Egan will speak about his experience with CIGRE and membership information on how to join. We will then have our last 4 presentations, followed by our second guest speaker from Jason Noctor, talking about the role of the Irish NGN and the different activities that the Irish NGN completes. And then to finalise or to end the event, we will have our winners announced and our closing remarks. So, just to give everyone on the event an overview of what the CIGRE organisation is and the role that it plays. CIGRE is a worldwide organisation that develops the exchange of engineering knowledge within the power system industry. So this slide demonstrates the wide area that the CIGRE organisation spreads to. As you can see, there is spanning 90 plus countries all over the world, including 60 national committees. This translates into approximately 15,000 members and growing. So as you can see, the network that CIGRE have is incredible and it's massive, and the network that you can be involved in is both informative and very, very useful for young professionals to join. So the CIGRE NGN, this is specifically catered for young professionals to develop their knowledge in the power system industry. It does this by completing industry-related events and topical events such as offshore wind, different things like that. Also site visits, so young professionals can go on site to different areas that will improve their knowledge in the power system and industry. The big selling point for the CIGRE NGN is the networking opportunities available for young professionals. It also provides a platform where early career professionals can feel comfortable sharing their ideas and get an opportunity to interact with industry experts, such as this event today. Also, it provides young professionals to get involved in technical events and working groups to further develop their knowledge of the power system industry. So now we are delighted to have 4 extremely experienced experts in the field of the power system industry. Our first judge is Robert Donaghy. He's currently a HV cables manager in ESB engineering and major projects. He was the Irish representative of Study Committee B1 from 2010 to 2016, and he is currently the chairman of the CIGRE Ireland National Committee. Robert's education is an engineering degree from the Dublin City University in 1992. He has a wide area of experience, which details 27 years in ESB International and ESB engineering and major projects. He's held various positions in the transmission and asset management areas and has been responsible for many major transmission cable projects in both Ireland and internationally. Our second judge is Dr. Paul Cuff. Paul is currently the assistant professor within the School of Electrical and Electronic Engineering. He is also a member of the Energy Institute. He is also a BE and PhD degrees in electrical engineering from the University College Dublin in 2009 and 2013. Paul's areas of interest includes core research interests are in the optimization and analysis of the electrical energy systems. He's also quite interested in the urban transport electrification, blockchain and data visualization. Our third judge is Marta Val Escuero. She is currently the Principal Engineer in the Transmission Innovation Department in EirGrid. Marta's education includes a BE in Electrical Engineering from the University of Zaragoza in Spain in 1994, and also an MPhil from the University of Bath, UK in 2007. Marta's area of interest include starting her career working in research in Spain, then moved to ESB International in 1997, before migrating to EirGrid in 2007. Marta has a wide range of grid solutions in all areas for the industry and for both system operators and customers. And also Marta is only one of 20 members in CIGRE's 100-year history to be awarded CIGRE Distinguished Member Award for outstanding contribution to CIGRE technical matters. Great achievement. Our final judge is Dr. Jeff Love. Jeff is currently a principal engineer with the Power System Consultants in the HVDC Studies Engineering. Jeff is currently the CIGRE B4 member for Ireland since 2018. Jeff's education includes a BE and PhD degrees in electrical engineering from the University of Canterbury. Jeff's areas of interest include: he started his professional career performing power system studies for the Transpower New Zealand Grid Planning Group. He then moved to the System Dynamics Group to carry out further power system studies before joining the Pole 3 HVDC team as a project and commissioning engineer. In 2014, Jeff joined the Power System Consultants as a senior HVDC studies engineer, now principal engineer, initially in Reading, UK, and now in Dublin. In this role, he's worked on power system studies and HVDC projects in the Ireland, the UK, France, and the US, and Scandinavian sectors. So a very impressive 4 judges that we have lined up today. So to give everyone an idea of our first of our 8 presentations, there are a variety of young professionals from various sections of the power system industry, ranging from EPRI, ESB, ESBI, UCD, TCD, and EirGrid. So we're delighted to have everyone on board today. And our first presentation will be from Camille Lemouf. So to give everyone on the event some guidelines on how we're going to run the event, we please ask everyone to mute their lines. And we're going to have each presenter is going to have 7 minutes to present, followed by a 3-minute Q&A. So initially, we're going to have our first question from our judges, followed by questions from our Slido application. So please feel free to include your questions in the Slido app. So Camille, please share your screen and you can start your presentation.
Thank you. Just to share my screen, you have to turn off yours.
Yeah. Work away there.
Lovely. Actually, do you see my screen?
Yep.
Great. Thank you. Whenever you want. Okay, I'll start. Well, hello. My name is Camille Lemouf. I work for EPRI's Electrical Power Institute, and I'm going to present you a new method to measure the wind speed using infrared thermography for transmission lines. But first, why should we use it? Joints or splices are used to hold conductors both to transmission towers or conductors together. They're the weakest point on the conductor because they're aging and they can break, and they break more often than others. Fortunately, we can detect aging joints before they fail by using infrared thermography. And this is the main detection method that is used at the moment. The electrical resistance of a joint is increasing when aging, and the bigger the resistance, the bigger the temperature. But the temperature also depends on the intensity of the current flowing inside the joint. More current means more heating. It also depends on the wind speed. More wind means more cooling. The problem is that for different conditions like intensity or wind speed, you will measure different temperatures, and you don't know which of those temperatures you should use to assess the risk of failure. So you need to extrapolate the measurement to a comparable and known external environment to be able to assess the risk properly. And this is usually what is done. So people are extrapolating the measurement to extreme conditions that can happen on the line. This would lead to maximum temperature of the joint. This would happen with the maximum intensity in the line and the minimum wind speed. To do the extrapolation, we're reverting the equation of the thermal equilibrium to identify the resistance of the joint. We want the resistance of the joint because this doesn't change when we change the external conditions. But to do so, we need the temperature of the joint. And we have it with the infrared camera. We can measure it. We also need the intensity of the current that is flowing inside the joint at the moment we do the infrared measurement. We have it from the current transformers at the surrounding substation. The last thing is we need the component of the wind velocity that is effectively cooling down the line at the moment we do the infrared measurement. And this is tricky because the infrared camera is usually mounted on a helicopter, and you cannot really install an anemometer on the helicopter that give you a precise measurement. So what people do is they ask the pilot to give an estimate of the wind velocity. And this leads to lots of false positives due to the uncertainty in the wind velocity given by the pilot. This is why we need a new method to measure the wind speed. With infrared camera, we can measure the thermal field on the joint. This is what we need, but we can also measure it along the conductor. Inside the green circle there, you can see the temperature. It's not uniform. Well, this is because there's an edge effect due to the heat conduction from the hot joint. And we can identify the wind velocity with the convection's heat transfer coefficient that is hidden in this heterogeneity inside this green circle. The temperature there follows an exponential law along the conductor, and the rate of the decrease is given by characteristic length LC in purple here. This characteristic length LC depends on stuff from the conductor, but also on HC, the convection's heat transfer coefficient. And this is the green parameter here. This convection's heat transfer coefficient depends on the conductor, but also on the wind velocity, and more precisely on the component of the wind velocity that is effectively cooling down the line. What is interesting here is that there's only one unknown, the wind velocity. So if you can get access to the characteristic length, then you can calculate the component of the wind velocity that is effectively cooling down the line. Well, let's do it. So I'm taking a dead-end joint that is overheating, and this is the infrared image on the left side. You can see that as predicted, the temperature along the conductor is not uniform. What I'm doing is I'm extracting the temperature along the conductor. This is the green curve on the right figure, where the temperature is a function of the position along the conductor. And then I try to identify the best exponential law I can get. And this is the orange dashed line. It's pretty good fit. Because I've identified this exponential law, I have its parameters. So I have the characteristic length that defines it. So in that example, this characteristic length LC is 111 millimeters. And we have 2% uncertainty from the method we use, pretty small. With that, I can calculate the convection's heat transfer coefficient HC, it's 4.88. And then I can get access to the wind velocity, more precisely the component of the wind velocity that is effectively cooling down the line, the one I want. And here it's 4.73 meters per second. But what's more important here is the uncertainty of that measurement of our value is only 9%. And if we compare it to what people are usually doing, they're asking the pilot. And on that specific case, the pilot told 6 meters per second. He got the information from the weather station at the closest airport, so not really close to this specific joint we're looking at. And we estimate the uncertainty at about 50%, but it could be way worse, especially because the pilot doesn't give you the direction of the wind if it's parallel or perpendicular to the conductor. And that has a huge impact on the way it's cooling down the conductor. Hence, that this method is interesting because it gives you a value that you can get directly from the measurement, but with a super precise uncertainty, like low error, and you can rely on it. Finally, to conclude, I showed you a new method to reduce the error in estimating the wind speed cooling down a joint, and it can help lessen the level of uncertainty when you evaluate the risk of failure of an overheating joint, which means we have a better assessment of the effective action to take with that joint, either the agency to act or the technical solution you should choose. I thank you for your attention.
Thank you very much, Camille. Bill, would you like to sort out the questions, please?
Yeah, that's perfect. We'll go to the judges first for the question, if that's okay. One of the judges would like to ask a question.
Okay, I'll. This is Robert Donaghy here, so I'll maybe go first. So, Camille, thank you very much for your interesting presentation. My question is there any data available which demonstrates the magnitude of the effect that a high wind speed has on the measured temperature of an overheating conductor joint, as opposed to a measurement taken in calm conditions? So are we talking about a few degrees difference or something more significant than that?
Oh, no, way more significant than that. And especially because usually when you do your measurements, the wind is not that big, and you want to extrapolate the measurement to a super small wind with a lot of intensity to get the highest temperatures a joint could get. And if you make like small error there, it has a huge impact on the final measurement you want to get to assess the risk of failure.
So roughly, what sort of difference in measurement might you observe?
In all the parameters we have there to extrapolate, the wind velocity has about 50% uncertainty. It's the biggest parameter.
Okay.
Playing.
Okay, thank you very much.
Thank you. And the wind speed. Oh, sorry. The wind speed.
Sorry, Farah.
Yeah, go ahead. Sorry.
Go ahead. No, go ahead. Go ahead.
No, just the wind speed can go from about 1 meters per second if you don't look at the direction to 10 meters per second. With that speed, usually you don't put an helicopter out, but you could still do the measurement, and this is a big change. So just assuming that it's 10 meters or assuming that it's 1 is not enough to be able to assess the condition of the joint.
Okay, thanks a million. There's just one question. Oh, sorry, yeah.
Bill, it's Marta here. Just a very quick question.
Work away.
Yes, congratulations, Camille, for the presentation. That was very interesting and very well delivered. Just have a quick question in relation to the project. Was this a theoretical project, or are there plans to commercialize this technique, or what are your next steps?
So all the methods, the process to extract the temperature and identify the characteristic length, which is the complicated part there. I couldn't speak about it, but it's, that part has been, there's a patent on that part when I was working for RT. And we haven't yet tried on the field to compare the measurement. This is something that still needs to be done. So we've done the first part to we have the modelization, and then we say, okay, what does it give if you really use it? And is the uncertainty super high so you don't try to use it? Or is it small and it makes sense to try to go look closer to what it gives? And so we are on the process to continue that. We've discovered that it's way more interesting that just using the pilot, and it was going further to make real measurement and on site and compare it to the method I'm proposing.
Thank you very much.
Thank
you. Okay, there's just one question in here on the slide, and that is, what method do you use to fit the exponential function to the measured values?
We tried different things. You can use a logarithmic value. You just assume that it's an exponential, so you make a basic linear regression on a logarithmic scale. That would work, but it doesn't work along all the conductor because there's problems somewhere. So you have like other techniques where you use integral solutions. It's good too. It gives better results. And the last one, you just optimize and find the 3 parameters that are there. And that works super well. So it's not the obvious one, but the numerical tools we have allows you to do such methods, to use them. If that answers your question.
Perfect. Thank you. I think that's all we have time for, so we might move on. Thanks a million, Camille. Thank you.
Thank you.
Great. Thank you, Camille, for the great presentation. Our next presenter, could you just stop sharing your screen there, please, Camille?
Yeah, sure.
Thank you. Perfect. Our next presenter
hello.
Hi. Sorry.
Hi.
Will be Varun Soni from ESB. Varun, if you just stop sharing, you can share your screen and you can work away.
Just do that. Is my screen visible there now?
Yeah. Thank you.
That's good. Thanks. I'll get going now. Good afternoon, everyone. I'm Varun Soni. I'm a graduate from Trinity College Dublin with a mechanical engineering degree and graduated in 2018 and joined ESB in the same year. As a graduate in Overhead Lines Department, I got the opportunity to get involved in a project concerning the stability analysis of the pivoted V insulator assemblies. And today's presentation on a tool to determine stability of a PVI assembly presents the work done as part of that project. Now, just to add a bit of background onto the problem, one of the biggest challenges faced by power utilities is to increase their existing transmission capacity. And this is due to the difficulties in obtaining right of way and minimizing the environmental impact of the new builds. So a popular alternative to the new builds is to operate the existing corridor of the lines using compact line design, such as pivoted V insulator assemblies. A PVI assembly eliminates the swing of the insulator towards the structure, towards the support structure, reducing the required clearances, and thereby reducing the overall footprint of the line, as can be seen in the comparison between the standard lattice tower and a compact tower employing a PVI design. A conductor in a PVI design is allowed to move longitudinally along the span, as the PVI assembly itself can rotate on an inclined axis of rotation shown on the right. Now, this rotation reduces the bending stresses on the suspension structure, but also allows for span balance for tension balancing between adjacent spans in case of longitudinal imbalance between them, as the PVI assembly swings towards the span with higher tension. However, in case of large imbalance between the span tensions, high enough rotation in a PVI assembly can be induced, which can lead on to producing clearance infringements and even contact between the conductor and the support structure in extreme cases. And this is why it becomes imperative to study the rotational stability of a PVI assembly for foreseeable operating conditions. And carrying out the study for an isolated PVI assembly is relatively simple, as the equilibrium position of it can be determined by a moment balance equation, taking into consideration the load imbalance, PVI design, and vertical and transverse loadings. However, the situation becomes far too complex when you consider a section with PVI assemblies, because what happens in a section is that the rotation assemblies in the rotation of the PVI assemblies in the same direction starts to accumulate over a series of span and result in inducing large rotation in the PVI assemblies in the later section of the in the later part of the section. And this is shown in the image at the very bottom of the slide. This snowball effect of the PVI rotation not only decreases the stability of the section, but also increases the risk of structure contact and face-to-face clashing due to reduced clearances. An equilibrium position of a PVI assembly in a section is not only dependent upon the sag tension, the weather conditions, or the PVI assembly design, but it also depends on the number of spans in a section and the rotation induced in the neighboring PVI assemblies. Thus, to determine the stability of a PVI assembly in a section, an analysis considering the rotation of all the PVI assemblies in the section simultaneously needs to be carried out. And this is exactly what the Excel-based tool does. The tool uses an iterative approach to determine the equilibrium position of the PVI assemblies under defined weather conditions by the user, while accounting for the rotation in neighboring assemblies. And the working of it can be easily explained using the process map included in the bottom of the slide. We start by inputting the data on the line design, conductor properties, PVI design, and the desired weather conditions. And what the tool does is from input data, it calculates the wind and ice loading on each span and determines the associated span tensions. Then it calculates the net longitudinal load for each PBA assembly. And in instances where a net longitudinal imbalance exists, the conductor attachment point for the PBA assembly is displaced by an incremental displacement value calculated by the tool itself. All the displacement between the displacement of the conductor attachment point of all the PBA assemblies is used to calculate new span lengths, which is then fed back into the tool to determine determine revised associated span tensions, and then again repeat the calculation of net longitudinal balance. If the net longitudinal load balance is achieved, the process stops there, and final output with the rotation angles of each PBA assembly is generated. However, if it is not achieved, the process repeats itself until a balance is achieved. Now, this tool was used to analyze an existing PBA section on our network, incorporating which had 4 PBA assemblies in it. Now, the graph presented in the top right shows the effect of wind pressure on the PBA assembly rotation, or the induced rotation, for given ice loading. And it can be observed from the graph that the angle of rotation shown by the y-axis increases as the wind pressure is increased. This allowed us to determine the stability and the clearance and possible clearance infringements for defined weather conditions with wind and ice loading. Furthermore, another study was conducted using the tool. Another comparison study was conducted using the tool between 2 different types of conductors, as shown in the graph in the bottom right. As can be seen from the graph, the conductor 2, which was slightly larger and heavier conductor compared to conductor 1, produced lower deflection than the PBA assembly for same weather conditions or same operating conditions. And this was a very meaningful insight into the conductor selection process. Now, coming to the last slide, and in an attempt to sum it all up, the tool provides us the ability to conduct stability analysis of PBA assemblies in a line section without the need of detailed line modeling. And it also allows to assess the proposed PBA designs by varying angle of inclination or the position of conductor attachment points to it. It further provides meaningful insights into the selection process of design parameters such as number of spans in the section, span lengths, and conductor selection process. Lastly, coming to the limitations, it is to be noted that the tool does require inputs on the considered spans and PBA design. Thereby there exists a need for preliminary design to be in place for it to be used. And it also requires the user to be well aware and read with the design methodology of PBA assemblies. That's my presentation. Thank you. And if anyone has any questions, I'm happy to take them on.
Thanks very much, Varun. We'll go to the judges first if they have any questions. Fire away.
Okay, I'll go first. Robert Donaghy here. So Varun, thank you very much again for a really interesting presentation, well delivered. My question is, how do you, or can you validate the accuracy of the stability analysis tool?
Yeah. So in the when you run the analysis, it does produce a convergence report as well. Since it is an iterative process, the solution only stops when the solution has reached a convergence. But if you're asking about the validation of the results produced by it, we can validate it using the PLS-CAD analysis, and this was done for the PBA assembly study that was done for the conductor comparison study. But we still do plan on using the tool for comparison with the PLS-CAD analysis for overall wind and ice loading conditions to determine the assembly stability.
Okay, thank you very much.
Perfect. If any other judges have a question, fire ahead. But there's just a question coming in here, and it's quite similar now, but it's asking about the comparison with PLS-CAD, and I suppose where do you see it fitting into the line design process? Will it be alongside PLS-CAD or as a supplementary tool?
I think the best use case scenario of the tool would be to optimize the design and finalize it, because it allows us the ability to make changes, to make design changes without making any significant changes to the setup, which would be the drawback of PLSCAD, because you'll have to go in and there's a good bit of work. It's a work intensive process to do in PLSCAD. It allows us to narrow it down to the final design, and PLSCAD model will need to be created anyways for other design checks. But this allows us this allows us to make the process more efficient of the design optimization.
Perfect. Thanks a million. Yeah, great presentation, Varun. Thanks a million. I think we're going to move on to the next presentation. Cheers.
Thank you, Varun. That was a very good presentation. Our next presenter will be Gurus.
Yeah, like see this, look. I sent it on SharePoint.
Just a second there.
Yeah, feel free to.
Can you see this?
Sent it on SharePoint here, like.
Thanks very much. That looks perfect there now. You can start whenever you're ready.
And then I have it here.
Sorry, John, just your mic's on.
Start. Should I start?
Yeah, work away when you're ready.
Yeah. Hi. Very good afternoon, first of all, to all present. My name is Gurus Singh, and I'm going to talk to you about a planning tool called the Generation Availability Capacity Map. Before that, a bit about myself. I've graduated in mechanical engineering from Trinity College, Dublin in 2018. After that, I started working for ESB as a renewable planner, where I basically worked on this project. I then moved on to the overhead lines design department in engineering and major projects, and now thoroughly look forward to becoming a professional engineer with ESB. ESB at its heart has always looked to provide a better future for its customers, maybe with the rural electrification program or the creation of Turlough Hill, or setting up the first wind turbines in 1998. We've always looked to innovate for a brighter future, and we don't plan to stop anytime soon. So to continue this forward, today we're focusing on how to connect renewable energy more quickly onto the Irish system. To do this, a solution in the form of an interactive map showing the available network capacity in a particular area or substation was proposed. So on the right-hand side, we can see a map of southern Scotland from Scottish Power Networks. What it's simply showing is that the areas in red mean that for any more generation to connect in those areas, significant reinforcements will be required. As we move on the green areas, it means that these reinforcements will be highly unlikely. Now, if you zoom into the map, we could actually see the 110 kV and the 38 kV substations, which are again color-coded on the same logic. If we click on these stations, we could see what capacity is available at each of those stations in megawatts. The dotted lines, then again, they are the transmission network and are color-coded based on the same logic. So we looked at them and other utilities as well that provide this information and figured out ways how we can implement this within ESB. So what I found that along with a lot of complex theoretical calculations surrounding load flows using different softwares, a lot of energy had to be focused on amalgamating the data from different sources. Sometimes this would have meant hard coding thousands of stations or hundreds of generators. But the aim was to come up with a format that was compatible amongst themselves as well as external softwares so that it was very easy to use and update for future years. So the way we decided to do this was in 3 phases. The first phase obviously involved a lot of benchmarking and research. We decided to go out to our customers and see what they wanted. So I presented the idea to the Irish Wind Energy Association, and we sent surveys to the likes of IVEA and ICEA. So we got their input, we took it on board, we came up with the map as I'm showing here on the right-hand side. Again, the dots here represent the 138 kV stations, where green basically means that significant capacity is available at those stations. Red means no capacity is available. The blue then means that these are the stations where the transformers do not operate in parallel and can have different capacities available. But if you click on them, you could see which transformer has how much capacity available. So now the third phase is then to provide the customers with even more data, such as the transmission network and say areas that have high solar and wind potential, and other information as well, which would help them pick up locations where they could set up their projects so we could connect them more quickly. Moving on to the benefits, what I felt for any renewable project to go through, it ultimately boils down to its safety and profitability. So we're saying that around 50% of the applications that are received in renewable planning don't accept their first offer for their application. This is simply because the customers have chosen a location that is close to a substation that is heavily loaded. And to connect them, we will have to charge them for any upgrades that they are driving, may it be protection upgrades or the transformer upgrades, or if the line is heavily loaded. So to connect them, they'll have to pay that. Now, this results in an expensive connection offer, rendering the project unfeasible. So the project ultimately falls down. The map is also then being used within the renewable planning team, making it easier for planners to identify connection methods at a high level. What I mean by this is sometimes we can have 7 or 8 or even more generators close to a station. In that scenario, we have to come up with what we call a least cost, technically acceptable solution for the entire group. So from this map, we could actually put, we have the coordinates of those generators. So we could see on the map where they are. We could see a lot of information, what capacity is available in the nearby station, what sizes the generators are, how far away they are from these stations. So we can figure out at a high level their connection method, and ultimately at a high level, the cost of each connection. And then we could go to the customers and say that, look, this is what your costs are going to look like, and ask them if they're happy enough. And if they are happy, then we can proceed with the detailed analysis. If they're not, then we can move on to the next project, which saves a significant amount of time off the planner as well. It then also helps to develop in the development and strengthening of the overall network. So what I mean by that, for example, here there are 2 maps. On the left, we have the map shows all the generators that applied under the ECP1 process. And on the right, you simply have a heat map showing the available capacity. So just if we just focus on the areas around Dunmanway and Bandon and Enniscorthy and Arklow, you can see a lot of generators in those areas. And I know that is where the wind blows, the sun shines. That is the highest area for those areas have the highest potential for renewable sources. But you could also look from the right that these areas are already heavily loaded. So what this means that most of those projects will ultimately fall away, leading to a lot of wastage of time. So if we could provide this information in advance to the customers, so they could set up their projects at good locations, at the green locations where we could connect them very easily, then ESP itself can also look at those areas and have plan include this in their planning reviews where they should develop their network effectively, all in all, to connect more renewable energy as quickly as possible and as safely as possible onto the system. Now, all in all, it wasn't that there aren't any risks involved, and there were some risks involved around copper thefts or around station thefts with the sharing of the location data. But we figured out ways around it, and we think that the benefits have outweighed the risk, primarily because it drives the quality, speed, and efficiency all up, all in all, holding the costs down. But even so, more importantly, lies at the heart of a strategy for innovating for a brighter future. Thank you. And any questions? And there's a link to the map as well over there. Thank you.
Thanks a million, Garces. Yeah, so I'll go to the judges again. If any of the judges have a question, fire away.
Yes, I have a question. Thank you very much for the presentation. Garis, for someone that has been working in generation access planning for so many years, I can see the benefits of this tool, and I'm delighted to see that it's publicly available. So I could ask you 100 questions about what the information is behind it, but just for the sake of time, I'll just ask you about the process of where the information that you present there is coming from, and what process do you have in place, and what efforts are required to keep it up to date, because data management is normally the biggest the big elephant in the room. And how do you ensure that the information that is provided to the public is reliable and is up to date?
Right, so you're right, that is the big elephant in the room. Saying that we have different sources, so whenever an application comes in, we feed it, we have a specific code for it, its name, its coordinates, so it goes onto a register. and then I've extracted that information from there. Then we have a separate information, as you know, that we publish the SLR load readings publicly. So the Summer Valley load readings are taken from there. And then we do internal load flow analysis on softwares like Synergy and other softwares as well. So, and then extracting data just basically in the form of an Excel file at the end of the day. And it is basically, if you look behind the files, it is basically an Excel file that will do all the job. And the map is basically populated from an Excel file that just has 4 or 5 columns at the end of the day. That's just about the name of the station, its coordinates, and the capacity available. And really, that's pretty much it. But how to get that data is the biggest thing. And also the most important thing was when we made this, the big thing was that we should be able to update it very easily. And so because of that, the entire process is automated. As I said, whenever the application comes in, they go into a register, so we can very easily extract that information. And that is the only information that changes very quickly. All the other informations, the Summer Valley load readings, they do change, but they're only after a year or so that we actually get them. So, so those informations change very slightly, and we can do that very easily. And to update it, it basically be, say, at max a week's job.
Thank you very much. And just kind of another quick question. Do you present transmission constraints as well as distribution, or only distribution?
No, so as ESP, we won't have access to a lot of data that AirGrid have. So for any transmission things, either we have to collaborate with them, which we haven't done yet, for any of the stations above 110 kV. So they would come into the next step.
Yeah, that may be an idea for future DSO-TSO cooperation to kind of expand this data.
Yeah, definitely. Thank you very much for that.
Thanks.
Yeah, you've actually answered a couple of the questions here. They're based around when you're updating and if there's any input from AirGrid. There's just a side question. Is it a useful tool to pinpoint highest priority infrastructure in terms of upgrading, etc.? So is it useful to pinpoint where it needs to be updated around the country?
I'd say it is, but only partially, because, you know, a lot of upgrades might be down to just the condition of the trafos. So it wouldn't cater into that. But it, of course, that's what I meant by saying additional data that we'll feed onto that is things around those that, all right, this transformer has already aged a lot. It's been in service for a lot of years. We need to replace that. So that is the next from a generation perspective.
Yeah, perfect.
Can I jump in with a quick question for Gursis, if that's possible?
Yeah, work away, yeah.
Hi, Gursis. Loved the presentation. Lots of nice images there. Lots of nice maps to look at. Forgive me if you covered it off, but I noticed on one of them you had certain stations marked in blue, and your legend said that they were mixed capacity stations, mixed capacity available. So I think we all kind of understand, like, traffic lights, like green is good, then when you got yellow is the medium amount of capacity, red is no capacity. So just could you expand a bit on what the blue means there?
Yeah, sure, Paul. Sorry, as I said, the blue means that these are the stations where the transformers don't operate in parallel. So say the other stations, you could have two transformers or 3 transformers, but they're all operating in parallel. So they'll all have the same capacities. But for these blue stations, there are more than 1 transformers which don't have, which are not in parallel. So which means that you could put different load on 1 transformer and different load on the second transformer. But of course, if you click on it, you could definitely see what capacity is available on each of those transformers. If you get that, if I explained that right.
Yeah. Okay. So it's really just that you know, if you were to kind of zoom in, you might see that one of those blue ones, it could actually be kind of a red on one side and a green on the other. Is that kind of what you're saying?
Yeah. Yes. Exactly. Yeah, exactly. There's a link at the
so kind of in an ideal world, you'd be able to show that on the map, but kind of blue is an interim solution, I guess.
Yeah. Either we could show both red or green over there, but that might just confuse people even more. So.
Yeah. No. Gotcha. That's perfect. Thank you, Gursis.
Cheers. Thank you.
Perfect. Thank you. I think we'll move on there to the next one, if that's okay. Thanks a million, Gursis.
Perfect. Thanks.
Thanks, Gursis. That was a very interesting presentation. Our next presenter will be, would you mind just unsharing your Thank you. Our next presentation will be Saeed, Misag, sorry, the pronunciation. Thank you.
Yeah, no problem.
So please feel free to share your screen.
Yeah, sure.
Thank you.
Thank you. Okay, sorry. So I should just share the screen. Yeah. You have it now, I think. Hello, everybody, and okay, thank you. Sorry. Hello, everybody. My name is Saeed Misarian. I'm a PhD researcher at University College Dublin, and I'm working with UCD Energy Institute, and my project is part of a multidisciplinary group called ECP, stands for Energy System Integration Partnership Program. And today I'm going to answer this question whether commercial demand response units can use as fast frequency response service as a solution to low inertia power systems. But what do we mean by low inertia power systems? Well, the rising concerns associated with climate change and greenhouse gas emissions have encouraged to integrate high shares of renewables within the electricity network, which of course brings new challenges for system operators. Because as you can see in the figure, we are going to have less rotating mass in the future system, which implies that we would have lower inertia in the system. So in this kind of systems, when a generator trips, the frequency tends to decline faster, encouraging the need for faster acting responses. In this line, power system operator across the world introduced new system services, one of which is fast frequency response. And although there are similarities between the introduced system service, the interpretation is different in its jurisdiction. Here in Ireland, as of relevance here, CIGRE, which is a transmission system operator of Ireland, defines it as an increase in generator output or a decrease in demand within 2 seconds following an event to be sustained for at least 8 seconds, with fast response also incentivized. But what's the approach here? In this work, we are interested to see if commercial demand response units can contribute to fast frequency response service. To do so, we need to know how demand response units of interest works dynamically. So we need to model, so in order to model its behavior, then the aggregate demand response unit will be integrated within the system scheduling as a source of reserve. And finally, the dynamic performance of the system will be evaluated. Supermarket fridge and freezers are considered here a source of fast frequency response due to their inherent thermal inertia and aggregate power consumption. Here you can see the mean across a year power consumption of 1,800 supermarkets, which have been simulated in MATLAB. Moreover, I should mention that 3 control strategies have been adopted in order to provide reserve to the system: static, drip, and hybrid control. In the static control, we say that, okay, switch off the entire fleet if the frequency exceeds the predefined threshold. In drip control, we say that change the temperature based on the frequency deviation. Indeed, it's akin to conventional generator drip, except for the fact that we change the temperature set point. So when the frequency goes down, we increase the temperature set point. So in that way, we actually and indirectly reducing the power consumption. In hybrid control, we change temperature set points based on frequency deviation and derivation of frequency deviation. The all-island power system of Northern Ireland and Republic of Ireland with a horizon of 2030, according to CIGRE documents, has been considered as a representative study system, and Backbone, which is a generic network optimization tool written in GAMS, has been used in order to do the unit commitment and economic dispatch scheduling of the all-island power system. And SFM, which is the single busbar frequency model of all-island power system developed in MATLAB and MATLAB Simulink, has been used in order to evaluate the performance of the system. In this figure, you can see how we bridged Backbone and SFM together. Indeed, the output of Backbone has been used in order to initialize the SFM. Numerical results shows that integration of demand response units results in 13 million euro cost reduction. However, having said that, deployment of demand response units as a source of reserve resulted in deterioration of RECOF, as it is illustrated in the figures. Look at the left figure in this slide. You can see that in case of losing the largest single link feed, the blue points which represent the case with demand response units tend to the right, which implies that if we lose the largest single in feed, we would have higher rate of change of frequency in case that we consider demand response units. In order to show it clearer, look at the right figure. Its statistical analysis shows that integration of demand response units increases the chance of having workup higher than 0.85 Hertz per second by about 25%. Now, in order to do the frequency stability analysis, a representative summer day with 68% SNSP has been considered. It can be seen that frequency nadir in all cases is not desirable, and due to the fact that the size of available reserve in comparison to the event size is small. However, you can see that the static and hybrid methods are the most effective at improving the frequency nadir. And I should say the worst response, the rose frequency nadir comes from the case in which demand response unit do not contribute to fast frequency response service. Another point that I like to bring here is that as a droop response depends on the frequency deviation, it results in a much slower increase in output as the frequency falls, and hence a steeper recurve and lower frequency nadir than the static and hybrid approaches can be seen. And now for the same system setup, a 40 megawatt unit instead of 20 megawatt unit is stripped. So we can see when the frequency goes below a threshold, the full demand response is activated in the static case, resulting in the best nadir improvement, but with a major drawback of over frequency shooting. As this response, the response of the static case, its response magnitude greatly exceeds the size of the event. However, in contrast, the hybrid and droops responses are as might be expected, with the hybrid response actually offering a faster active response. But finally, what's the best scheme? Considering having enough reserve in comparison to the event size, we can say that considering the rate of response, providing a faster response, and of course, providing a response proportional to the size of the event in order to prevent overshooting frequency, I can say that the hybrid method performs the better than two others. And finally, thanks very much for your attention. I'm glad to discuss if there's any questions. Thanks very much.
Thanks a minute, Saeed. Great presentation.
Thank you.
So yeah, again, we'll go to the judges if anyone wants to fire ahead with a question.
Hi, Saeed. So this is Pokos here. You showed on slide 6, I think it was, slide number 6, you had two kind of fairly involved scatter plots. Next slide after that.
This one.
This one here. Now, I'll confess that I didn't fully understand what I'm looking at there on the left-hand side. Could you just talk me through that again, please?
Yeah, well, we consider two cases. In one case, we have demand response units a source of fast frequency response reserve, and in one case, we didn't consider any demand response units. So the response come from other competitors like interconnectors or wind farms. So this figure shows that in case of losing a large single infeed in the system, for example, that might be an interconnector importing power from Ireland to Great Britain. So in that case, what would be the rate of change of frequency in two cases? So the orange dot shows the case that we don't have any demand response, and blue point shows the case that we have demand response. And actually, this figure shows that the blue points tend to the right, implying the fact that we are having higher rate of change of frequency when demand response are in the system. And that's because of the fact that we have lower...
Like we're looking at the marginal distributions you've broken out to that right figure. Yeah, no, that makes sense. Yeah. Thank you so much.
Yeah, my pleasure.
Perfect.
I have another question.
Yeah, we're going, Marta.
Sorry.
Yeah.
Just kind of congratulations for this excellent presentation and a very kind of interesting topic for Ireland in particular. Just kind of have a quick question about the performance and the requirements for this fast frequency response. So do you have any insight on the relationship between speed of response and required volume for curbing the the rate of change of frequency. Do you have any kind of method of optimizing how fast do we need that reserve to respond against the volume that is required to be procured?
Well, to be honest, we didn't consider this kind of sensitivity analysis in order to figure out what should be the response and what should be, I mean, in comparison to the event size. No, we didn't consider it, unfortunately.
All right, thanks.
My pleasure.
Perfect. There's just a question on slides 4 and 8, just on the technologies to the left. Could you describe them or explain what they are?
Yeah, well, we considered, it is very important for us to consider a model which is close to reality. So we contacted Danfoss company in Denmark, and we got a very detailed model of a supermarket, which is in Aalborg University. So what we did, we tried to simplify that model in a way that we could consider an aggregate number of them, because when the numbers go up, you know better than me that the computational complexity goes up. So we simplified a real model, a real supermarket, which is located in Aalborg University, and then, yeah, we use it. We simulate it in MATLAB Simulate, and MATLAB Simulate.
Perfect. Thanks for that. I think we might move on there, but thanks for the insight. Thank you.
And my pleasure. Thank you.
Saeed, thank you very much. That was a very interesting presentation. A lot
pleasure.
of work involved.
Thank you. I should stop sharing, yeah?
Please, yeah. Thank you.
Yeah. Thank you very much.
So thank you all, our first 4 presenters. Some great, really in detailed presentations. I think it's a good time for a 5-minute break. So I'm going to just start a timer here. And I welcome you all to come back in 5 minutes, where we're going to actually have the last 4 remaining presentations. So thank you very much. Welcome back, everyone, and welcome to the second part of today's presentation. We're going to listen. We're going to have our first of our two guest speakers for today. Our first speaker will be Conor Egan to talk about his experience with CIGRE, and I'll pass it over to Conor.
Great, cheers, Conor. Yeah, good afternoon, everyone. My name is Conor Egan. I'm working here at CIGRE, and I've been here for the last 4 years. I've just been asked to give a quick overview of my experience with CIGRE and kind of the benefits I've taken from my involvement, I guess, with it so far. Hopefully you can all hear me okay. I broke my headset earlier today and had to run out and get a quick replacement in Terni, or it's like something that came out of Smith's toy store, so it could go any minute, so apologies if so. Yeah. And then, yeah, so look, I know Conor's given a quick overview of kind of CIGRE generally, so I won't jump into that again. Kind of in terms of my own involvement, my first experience with CIGRE came in 2017. I presented at the CIGRE symposium that was held in Dublin. Like, I was only a graduate at the time. I had very little experience, but I was just given an opportunity to present on a residential demand side project that I'd been working on since I had started. It was called Power Off and Save. I ended up presenting in a session with projects of like similar nature. There were presenters from all around the world. I think there was maybe 200, 250 people with a Q&A session and everything afterwards. And like at the time, I just didn't really have a clue what was going on. I hadn't been in a presentation like that before, but like, and I didn't really know much about CIGRE. Didn't know what I was going to get from the organization, but I'd been recommended to present from my senior team lead within CIGRE at the time, pushed me towards it. And like, it was a really interesting introduction into the organization. I got a real feel for how kind of enthusiastic people were to technical content, and I guess how there's such a broad range of kind of participation across the industry, and like that's nationally as well as internationally as well. And then in 2018, along with Papia Latare from EPRI, I co-founded this CIGRE Ireland Next Generation Network and went on to organise and coordinate a number of events over the following year. This was kind of actually a very interesting experience that like involved making committee structure proposals, budget proposals, event pipelines, and submitting them to the Irish National Committee, who would make kind of approvals on our plans. That was quite an interesting experience. I wouldn't have done anything like that before, except through societies and college and stuff like that. And I guess, CIGRE is an international organization. There's a head office in Paris, but each country has their own national committee, which is made up of like senior technical experts from around the national like electrical system industry, who actually coordinate CIGRE activities in their country. So like even initially for myself, just give opportunities to kind of start building connections and working relationships with people in senior positions in organizations where like people were heavily involved in support of CIGRE and acknowledge the benefits of it. And then since last year, I've also been a member of the CIGRE National Committee, kind of so helping them organize and run events and specific tasks within the committee. That's briefly summarizing my involvement, but like I kind of want to talk about what I see as the key benefits I've taken so far from my involvement. And Conor Mulholland mentioned it in his introduction, but the primary one being the platform it offers to build a network of connections within the industry, like again nationally and internationally. Obviously, it's great to be able to present papers and deliver presentations to a technical and like quite industry focused audience. And again, who are very enthusiastic about what you're speaking about, but in particular, like there's a very unique opportunity to network with peers from other organizations who you might know about, but not have any opportunity to meet them, and you're building connections within them in the industry. Especially if you're a graduate or a young professional, like you're coming in, those opportunities are quite rare at the early stage of your career. So like, if there is a forum to do that, it's well worth taking advantage of that, especially on technical content. I'm sure most people, if anyone who is here has been on graduate programs or very early stages, you'll have presented to beta band and competency learnings as part of graduate rotations, but you're not getting into the detail of technical ins and outs of power flow analysis. So that's what I would say. There's a big unique benefit to this in that sense. And look, there's CIGRE running a number of events, and there's symposiums, and there's CIGRE Paris, and they're all brilliant. But you're not attending these events to be able to walk out of each presentation from all the study committees and immediately summarize all the key points. You're there to meet like-minded people in a similar position as you, I guess, and kind of build those connections. The events we've been we have been and intend to continue running are to offer that opportunity for people to present on and listen to that technical content while building up a broad range of contacts and networks from different organizations. Like for example, like I build up connections across ESB, UCD, EPRI, who may not and do not work in areas that I have any remote connection to at the moment. But I know in later years I've built up those contacts to be able to touch base with them and act as touch points among people who are knowledgeable in those areas, and likewise them for myself as well. And I guess I suppose as well as that, there's the peer-to-peer networking side of it, but like there's visibility that comes with kind of like your networking upwards as well. Firstly, within your own organization, it gives you an opportunity to kind of gain visibility with those technical experts who you were meeting and you were presenting to and you were working with, with that technical focus. Again, people who respect the CIGRE and acknowledge its benefits, but then as well externally, it can help start building a name for yourself in the industry, which normally can take time, especially in your early stage of your career as you're learning your trade per se. I guess the challenge with that in times of pandemic like now is how to replicate those benefits when events are being run virtually. Like today's event is perfect to give people presenting opportunity and to present and listen to technical content. But something we might need to look forward to in the future, and especially if we see new members coming in and trying to kind of replicate that benefit for them, is to kind of bring that networking element into what we're doing. So if we are getting numbers and if people are joining, which would be brilliant, we'd likely need to consider organising some sort of sessions where attendees can almost break off into Zoom rooms of 4 or 5 people just for 5 minutes or 15 minutes at the end of a session, just to be able to try replicate that catching someone for a coffee or catching them for the sandwich outside the meeting room, because that is quite important. That's what lasts from those sort of events. Yeah, and I suppose it's not as if COVID isn't going to be going away tomorrow, so there has to be ways to kind of realize those benefits for everyone, even as we continue. Yeah, and look, I said I keep it short. I know there's a lot of other presentations to get through. I suppose that's the benefits I've taken so far in my involvement, and that's since maybe 2017, 2018. Conor, do you want to maybe just move on to the next slide, just briefly?
Yeah, of course.
If you think it's something that you might be interested in terms of joining up, by all means, you can contact. I would recommend firstly getting onto the mailing list and signing up for the membership. You can contact myself. I think my email was. I'm not sure if my email was on the first slide, but if not, Bill Shannon, who's our secretary, would have been communicating to you about the events. I definitely would send an email, even if it's just asking for more information, and we can forward stuff out to you. Like the membership fee, in the scheme of things, it's not that much. It's definitely worth, especially for the NGN, in terms of people who be eligible for the NGN. There's a young membership of €45, even just to get a feel for and suss out what's available, what you can get from it. It's well worth it. Yeah, so I think that's it. I just want to say well done to those speakers who've presented already. They've been fantastic presentations, and best luck to those who are going to present now. Thank you.
Thanks a million, Conor. That was very informative. Great outlook into what you can achieve by being part of CIGRE and the opportunities that you can get. So thanks a million for that. Again, if anyone has any queries about becoming a member, please feel free to contact either myself, Bill Shannon, or anyone on the committee, and we can forward out any information. So now we're going to move on to our next 4 presentations, starting with John Whelan. John, can you just please share your screen there? I'll give you, and you can start whenever you're ready.
Yeah. Just want to try to get this in. You can see my entire screen there, can you?
Yeah.
I'll just stop for a sec and then put it into. Is that working now? Is it? Can you see my title page, or is it?
Yeah, that's perfect. Thank you.
Okay, grand. Okay. So welcome to my presentation. As you can see, my name is John Whelan. I'm an electrical engineer, and I've been working for ESB's Engineering and Major Projects division for the last 3 years. And then over the last 18 months, my work is focused on a 220 kV busbar reconfiguration project in Figlas substation in North County Dublin. So I'm just going to run through the project itself. I'll give you an insight to the substation and the scope of the project, implementing the project, and then the associated benefits with the project itself. So here is Figlas substation. So it's a huge substation. It's located off the M50 at Junction 5 in Dublin. It's a vital node in Ireland's transmission network. It actually accounts for the largest demand of all substations in Ireland and accounts for approximately 8% of Irish customers. I've just highlighted some areas of the substation here. So there's a wide array.
Sorry, John, just to stop you. It's not perfectly working there. We can see kind of the entirety of your screen, and then there's a bit cut off at the bottom. Just maybe try something else there.
Okay. Is that better now?
Much better. Yeah, that's perfect. Perfect.
Grand.
Cheers.
Sorry. Okay. So I've just highlighted some of the key areas in the substation here. So there's a wide range mix of technologies. 220 kV, 110 kV AAS and GAS, 38 kV indoor AAS, and then there's 2 control buildings. So there's a control building, the old one here, and then a new control building which has been built as part of my project. So the scope of this project. So what is the main task here? So physically, to construct 2 new wing coupler bays at either end of the 220 busbar, construct a new inline sectionalizer bay in the center of the busbar, and then also a new cable bay to cater for a connection to Belcamp substation in North Dublin. So that's the physical aspect of the project. And then electrically, a new Toshiba GRB 100 busbar protection scheme is to be installed to cater for all 14 bays. The 5 new bays will go straight into that scheme, and then the 9 existing bays will be transferred into that scheme. So all of this work is to increase the security of supply at Finglas, increase the flexibility, and then crucially, the connection to Belcamp is allowing for the connection of a large data center in Belcamp station. So that's the sole feeder to that substation. So implementation of this project, like all ESB projects, safety I think is paramount. Acting PSDP, like all projects, it's important to have a good plan in place. Because the demand in Finglas is so great, outages there are very, very tight and have to be kept to a minimum. So any work that is completed has to be completed very efficiently. So I've liaised with Ergen and ESB networks to go through various outage programs to get the project delivered. Then electrical design. So I've completed electrical designs to implement the new busbar protection scheme and to transfer the existing bays into the new scheme. So it's a challenging task, obviously a brownfield site. I've got very used to using kind of old TRO type drawings like you can see there, and consulting with our standards team regularly. There's also quite a lot of decommission then to take place. So any old DC supplies, position indication cabinets, remote control cabinets, and then the existing busbar protection scheme. So it was developed by ABB in the 1970s, so it's seen as quite unreliable and troublesome at the moment, so that's why it's being decommissioned and removed. So project progress. Both wing coupler bays have been fully built and commissioned. New cable bay for Belcamp station is fully built and commissioned. New control room to house the new scheme is commissioned. It's so each bay has a dedicated cabinet and has a GRB bay unit. So the bay units, they take in their measurements and their measurements from the bay outside and feed this information to the GRB central unit. The central unit then, based on its measurements that it's receiving, it uses differential protection then to determine any protection decisions that it needs to make in the station based on the varying zones and how it is set up. Then the SCS architecture is also complete, so you can see the difference in footprint that station control system and communication system from the old hardwired RTU type to the new SCS. It's a huge difference in footprint and efficiency, really, a reduction of cables and time and cost. Luckily, we have a great team out on site. I've led the pre-commissioning of 6 bays that have been transferred into our new scheme, and you can see here a photo of myself, our commissioning team, and also our team of network technicians. So the associated grid capabilities that are coming about thanks to this project. So there's obviously an increased flexibility at the substation. The 2 new wing coupler bays give, they really multiply the different busbar layouts, and they will decrease outage periods and increase the availability of the busbar, which is key in a station that has such high demand. An increase of security and quality of supply. So there's a huge influx of ICT industry in the North Dublin area, the likes of Amazon, Intel, and all these big tech companies. They are attracted to Ireland, and because of the security of supply and the good quality of electricity. So it's important that we build this and build on it, and build on this infrastructure and continue to attract these industries. And as I mentioned, the development of Dublin as an ICT hub. So for instance, the new bay in Finglas there, Belcamp, as I said, it caters for a large data center, and there's a number of projects ongoing in Dublin at the moment to keep building on the grid infrastructure around the Dublin area and to cater for the increase in demand and ultimately boost the Irish economy. So that's it, and I welcome any questions that you may have.
Thanks very much, John. Sorry for cutting across you there. Stopping your flow.
Thanks for doing it.
Always, if any of the judges have any questions, fire ahead.
I have a question. John, congratulations for this excellent presentation. It's a very interesting project and kind of highly needed. Yes, my question is for your insights into what was the most challenging aspects of the project and what was your role on it?
Yeah, well, obviously we, like in my electrical designs, you're interfacing with technology that has been there for the last 50 years, and it may not necessarily, you could open your schematics and have a look, and commonly like your drawings don't actually match your installation. Also then you might come across some old kind of auxiliary relays, anything like this that you need to really replace and get in like better assets. You know, like while we are doing work, it's important to upgrade things. So there's various challenges. It's hard to foresee them all, but probably just marrying into the old existing wiring is probably the biggest challenge.
Thank you. I believe that, yeah. Thank you.
So, John, Robert Donaghy here, and again, congratulations on a really good presentation. I've just a question in relation to the outages. You mentioned that in your presentation, and Finglas is a critical station in the Dublin network. So you were under obviously great pressure to keep outages to an absolute minimum. Can you give us a sense of what outages you actually needed to do this work? Like, were they just bay outages, or were they full bus bar outages, or half station outages? And how did you minimize the duration of those outages in the manner the work was conducted?
Yeah, so for each bay transfer, that bay is out for the duration of the electrical construction. And then during commissioning, they would have different busbar changeovers to basically facilitate the adjacent bays and keep as many bays on as we can. And I suppose in terms of keeping them to a minimum, resourcing is a main one. If we can have 2 engineers pre-commissioning, it's obviously much more efficient, and obviously COVID-19 didn't help with that, but it was just, I suppose, project planning and planning our resources ahead of the outages, making sure that we had all our designs in a good order before we even got to site, and that we went through the installation with the lads when we got to site, and just to make pre-commission and commissioning as efficient as possible, I suppose.
Very good. Thanks, John.
Perfect. Thanks a million. Cheers, John. We might move on there just to keep things going, but thanks a million. Thank you.
Okay. Thank you.
Thanks, John. Great presentation. Interesting project. Our next presenter.
Hi.
Will be Juan Gonzalez Sopeña. So, Juan, would you like to share your screen, please? And you can start whenever suits.
Yes. Hi, can you see my screen?
Yeah, perfect.
Perfect. Perfect. So, hi, my name is Juan Gonzalez Sopeña. I am currently a PhD student in Trinity College Dublin. And I'm here to show you how using a tool as wind power forecasting, together with the data nowadays available in wind farms, can help Ireland into moving forward into a greener future. So currently, one of the biggest challenges Ireland is facing is the further integration of wind energy in the electric grid. Especially since last year, the government set a target of 70% electricity coming from renewable energy sources by 2030. Compared to traditional sources of energy, wind is a volatile resource. Then we need a tool, wind power forecasting, to know beforehand how much wind power will be available for the next hours and the next days. For industry practitioners, this is widely used in the energy market for both participants who buy and sell energy, and also the operators who are in charge of maintaining an adequate energy supply, and also for the operation of reserves. Well, improving wind power forecasting, if it's one of the goals of the research project, WindPearl, that both Trinity and UCD collaborate. further information can be found on this link. Also, we are working on, for example, anomaly detection. That is also important for that. And the main goal of this project is to save and reduce operation and maintenance cost of onshore wind energy. But why do we need to obtain more accurate and precise wind power forecasts? First of all, it has been proven that the better the forecast, the more money we can save. Second of all, to reduce wind curtailment, allowing to generate more electricity from every wind turbine, and therefore increasing their economic and energy efficiency. And lastly, to improve and facilitate the decision-making process, for example, for participants in the energy market. And how are we trying to obtain these more accurate forecasts? By developing bespoke data-driven forecasting algorithms, and then testing these algorithms using real data from Irish wind farms. So regarding that, I wanted to show you a simple case study where we use wind turbine data to obtain improved wind power forecast for Ireland. So although it's a fact that is known that using data in a turbine level can lead to more accurate forecasting models that predict better wind power, is something that is often overlooked in practice, and practitioners tend to use wind farm data instead, considering the whole wind farm. So here I have developed a case study using data from a wind farm located in the west of Ireland. And what I have done is, on one side, I have fitted a forecasting model using data on a wind farm level, and then fitting the same model for every wind turbine, and then aggregating the forecast to compare both results. Just for your knowledge, the main element of the forecasting model that I have used here, it's a neural network approach known as extreme learning machine that it's very handy for wind power forecasting because compared to other neural network approaches, the training is faster, and that allows to to retrain faster the model if new data comes in and the model needs to be retrained. So in this figure, basically what I saw is the testing set that I have used from this wind farm. And at a first glance, we could see that the results are similar. So therefore, I am using two very common metrics to evaluate the accuracy of forecasts that are here, mean absolute error and root mean square error. And we have defined the improvement using the values of these metrics, where MWT is the value of any of these metrics using wind turbine data, and then MWF is the value of these metrics when using data on a wind farm level. So we have run simulations for different predictions horizons up to 6 hours ahead. And what we can see is that using wind turbine data allows to obtain even a 12% improvement in the forecast accuracy. And therefore, this, allows to have better information in the future for wind power. What's the impact of this improved wind power forecast? Short term, facilitate even more the decision-making process, as I mentioned before, for the energy market, and also to keep decreasing the operation and maintenance costs of wind farms. Long term, having better wind power forecast will allow to successfully increase the penetration of wind energy in the electrical grid, and therefore helping to establish a greener future and a greener economy in Ireland. So, well, that's all. Thanks for your attention. And if you have any questions, feel free to ask.
Thanks very much, Juan. A great presentation. Yeah, so I'll ask the judges if any of you have any questions. Fire away.
I'll ask a question. Congratulations, Juanma, for a very excellent presentation and a very kind of relevant topic. You made kind of a comment in one of the slides about the relationship between a good wind forecast and a reduction on the level of wind curtailment. And
yes,
I think that this statement may not be so intuitive for most people, and I wonder if you could elaborate on that relationship between the forecast and curtailment.
Yes, the idea is if the better the information we have in the future regarding every wind turbine in a wind farm, the better we will know if we can obtain energy, if we can extract energy or not from that wind farm. For example, if we know that tomorrow there will, let's say that the wind speed will be low and not enough to even start the wind turbines, then we can just say, okay, we don't, we cannot use it. So then we can extract the energy either from other wind farms or from other sources. And also the other way around, if we know that the wind speed will be high enough to extract energy from that wind farm, then the better that information is, the better we will know, the better we will use the resources we have to obtain electricity. I don't know if that makes things more clear or not.
Sort of. No, I'm just not kind of see the direct relationship with curtailment. So is there any kind of clear improvement that we can get out of a better forecast?
Well, I would say also together with the forecast, as I mentioned before, we are also working on anomaly detection. So we are researching on how to better know when a wind farm is not working and what's the reason behind, to get a better understanding of that. Every little thing that what we can do to increase the efficiency both economic wise and energy wise from the wind farm.
That's right. Thanks.
Thank you.
Thanks a million. We might move on from there. We're falling a little bit behind time. So thanks a million, Juan. Great presentation.
Thank you.
We'll move on. Thank you.
Thank you, Juan. Very, very interesting indeed. Our next presentation, our presenter is going to be Anne Jukan from UCD. So, Jukan, would you like to share your screen there, please? And you can start whenever. Yeah, perfect. Thank you. Sorry, Andrew, I think you're on mute there, I think.
Sorry.
Perfect.
Greetings, everyone. My name is NGN Kathagramanathan, and I'm a final year PhD student at University College Dublin. So today I will be talking about how buildings can be used to be a part of the future smart grid through grid interaction. And this fits under CIGRE Study Committee C6. So in particular, today's talk will be about how one particular approach, reinforcement learning, can be used to enable districts to participate in demand side management. So to give a bit of context first, buildings account for 40% of the global energy use, and this corresponds to 30% of greenhouse gas emissions. Grid interactive buildings are increasingly seen as vital for the smart grid, as demand side management is increasingly being shown to be more cost effective and environmentally friendly than other alternatives such as wind curtailment or peaking plants, as some of the other presenters have mentioned before. Buildings can achieve this flexibility through numerous technologies and assets as shown in this figure here. Now, the benefit is that a lot of these assets are already existing, and so this load flexibility can be achieved with existing assets. However, to do this without sacrificing occupant comfort, an automated control framework is required. Now, reinforcement learning has gained notoriety in recent years. For example, Google DeepMind designed AlphaGo in 2016, and this reinforcement learning agent was able to beat Lee Sedol, the world champion in the game of Go. Reinforcement learning has also been applied to achieve superhuman performance in games of Atari. Now, increasingly, there's more attention on the use of reinforcement learning to solve other real-world challenges, and that also applies to the power system. So just to give a quick brief on reinforcement learning or introduction, it's essentially a machine learning technique where you have an agent that learns from experience. So for every action it performs on an environment, it is either rewarded or punished, and based on that reward function, it learns from this experience. Now, it's very promising because of its potentially model-free nature. Essentially, you do not need a model of the environment for the agent to learn an optimal control behavior. Further, it's also adaptive. So given changing environments and given further experience, the agent is able to modify its behavior and optimize to the new environment. This is especially important as no one building is the same. All buildings are either designed differently, constructed differently, or occupied differently. The majority of studies in reinforcement learning to date focus only on single buildings with demand-independent prices, so this might end up just shifting the peak rather than flattening the peak. And finally, deep reinforcement learning has often been limited to discrete or low-dimensional action spaces, as the previous examples. CityLearn is an open source environment designed at the University of Texas, Austin, that aims to provide an environment for benchmarking reinforcement learning agents in the district demand side management problem. It's also open source, and it provides 9 buildings with pre-computed cooling loads from Energy Plus high fidelity simulation, and it allows the control of domestic hot water and chilled water to provide the flexibility needs. The CityLearn Challenge, together with the University of Texas, Austin, and IBIPSA, the International Building Performance Simulation Association, was held in early 2020. And this competition asked participants to design, tune, and train a reinforcement learning agent that was to meet a multi-objective cost function that included minimizing ramping, maximizing the load factor, minimizing the average daily peak demand, minimizing the electricity peak, and minimizing the total energy consumption of a district of 9 buildings. I participated in this challenge together with Kasper Twardarski, a master's student also from UCD, but from computer science, and together we submitted an entry to this competition. We went with a centralized approach. So essentially this is one deep reinforcement learning agent or controller that controls the 9 buildings. So this figure just gives an idea of some of the states that the reinforcement learning agent sees. So the information we feed the agent include the electricity price, ambient weather conditions such as solar radiation and external temperature, the hour of the day, and also state variables such as the state of charge of the storage devices. We also applied a simple reward function based off a time of use tariff-based idea. We employed a soft actor critic algorithm, which is essentially an off-policy maximum entropy actor critic algorithm, first proposed by Hanoja. I won't get into the details of this algorithm in particular due to time constraints, but feel free to ask questions or contact me after this presentation. So this quickly shows some of our key results when we trained and deployed this reinforcement learning agent. So it's compared to a manually tuned rule-based controller. Essentially on the figure on the right, scores of less than 1 show a better performance than the manually tuned rule-based controller. And after about 10 episodes or 10 epochs of training, we can achieve better performance. And this is shown on the bottom figure where we plot the district power demand for the 9 buildings. And the figure in red shows the optimized district power consumption or demand, as opposed to the dashed line in black, which shows the rule-based control. And we achieved an improvement of 10.7% averaged over the 5 cost objectives when deployed on the same climate zone. This solution is also adaptable. When tested over different climate zones, we were also able to achieve scores of less than 1, showing an improvement in performance. Finally, my conclusions and contributions are that a soft actor-critic deep reinforcement learning agent was proposed for the district demand-side management problem, and the agent was able to reduce the 5 cost objectives when applied to different climates and also different buildings, showing its potential as a robust plug-and-play style controller for buildings and districts for demand-side management. Some of the limitations are that scalability over a larger number of buildings is still unknown, and the manual and time-consuming reward shaping applied. Finally, future work involves looking at decentralized approach or a cooperation-based approach together with Politecnico di Torino, where we're collaborating, and investigating the case of individual buildings who might have their own independent objectives. Thank you very much, and I look forward to your questions.
Thanks very much, Njukan. Great presentation. So yeah, I'll let the judges fire away with any questions you might have.
Okay, I'll go ahead. Congratulations again for the presentation, really interesting, and I see great future on deep reinforcement and artificial intelligence in the energy sector. So just kind of a curiosity for you, it's just, what do you think the barriers and enables for the deployment of this technology as business as usual could be, and what timelines do you foresee for deployment of artificial intelligence in the energy sector?
Yeah, so that's a good question. So this reinforcement learning has gained a lot of interest in the research and academic communities in recent years, whereas I guess commercial applications are a bit more limited. One potentially maybe successful example of commercial utilization is Google again, employing it on their data centers. I think key challenges are still related around stability. For example, in mission critical environments, the stability of an agent is still not well understood. And finally, training is also potentially quite a computationally intensive or time or experience intensive process. So we need approaches to, I guess, either learn offline or learn faster. And this is an active, I guess, research area.
Perfect. Thanks a million for that. Sorry.
No, thank you very much. Thank
you. We might move on if that's okay. There's no questions coming through, so we might move on in the interest. Okay. Thank you.
Sure.
Thanks a million, Njukan.
Cheers, Njukan. Very interesting. Fair play. A lot of work involved. Our last presentation will be from James Marr. So, James, would you like to share your screen there? And you can start whenever you're ready.
Sweet. Perfect. So, good afternoon, everyone. My name is James Marr. So my title is Phishing Emails and the Power Industry. I'll be talking about some preventative measures also along the way, and just sort of a preface on some of the stuff I'll be talking about. I can't really go into too much detail on some of the specifics within AirGrid, obviously for security reasons. But just I think I gave a good couple of examples on how it can definitely affect the power industry, and just some more back-end info on phishing in general. So just quick table of contents. I'll start with what is phishing, the types of phishing, a bit of psychology of phishing, the AirGrid's current approach, the possible implications for the power industry, and just a small conclusion at the end. So quickly, what is phishing? It's a form of social engineering. So social engineering would basically be, for example, like pretending you're someone that you're not. So maybe pretending that you're a repairman and gaining access to someone's server room or something like that to implant something malicious. Everyone is susceptible to phishing, no matter how much training you have. Everyone has their weaknesses, which follows on to my next point. So everyone is affected with different tactics. At least 3.4 billion fishes are sent daily around the world. It's a recurring problem. It's never going to slow down. Fishes are designed to target the biggest weaknesses in companies, which unfortunately is us. 90% of data breaches are down to humans. Attacks in power industry can result in catastrophic incidents, which I'll go into later as well. And then opportunistic individuals. What I mean by that would be something along the lines of this. So obviously we're living through COVID-19 at the moment. And around March the 8th, there was a massive spike with COVID-19 related phishing attacks. So people were getting emails saying that they came in contact with a person who tested positive, or some cases people said that that person actually receiving the email had tested positive. They could be filling in their credentials and then once they fill in their credentials, their email could be gone or something else could be taken away from them essentially. So just moving on into the types of phishing. So there's like traditional phishing email with a malicious attachment. So this might be like a Microsoft Excel document or a PowerPoint even. They would have like macros enabled inside this, and from there then they would compromise systems. Spear phishing campaigns, mass phishing campaigns, and whaling. So spear phishing campaigns would be like targeting a specific company or a group. Mass phishing campaigns, the best example I can give for this would be, imagine you're casting a giant net essentially, which is an email into the internet, and whatever you get back is your catch, I suppose. And then whaling finally. So this is targeting things like CEOs, CFOs, CTOs, so the big names and companies. Phishing emails with embedded URLs. So this is just like hyperlinks, URLs hidden behind pictures, so sort of hidden in plain sight. Phishing emails that redirect users to fake websites, so man-in-the-middle attacks. These are very prevalent in sort of the financial departments within companies. So even within the power industry, EirGrid, for example, we run the market, so there's a lot of money going back and forth. So it's a sort of a big deal if something was to happen, like a man-in-the-middle attack. So, for example, you could receive a URL from your bank apparently, and you would click the link, fill in your details, and it might come up that you have entered your password wrong. But in actuality, you've entered your correct credentials on a fake website that an attacker is going to use on the correct website, and essentially they can perform different things with your money or whatever they want to do. Then phishing or phone calls. So this is when someone calls you and pretends they're someone that they're not. And then text messages, WhatsApp messages, which is smishing, which I'll give an example of next. So just with the different tactics that I spoke about a while ago, the younger generation would be more affected by things like PayPal phishes, social media phishes, and then the super value smish, which is a text message. This would affect like a lot of the older generation. So my father actually fell for the super value one before. We had to cancel his credit card. That's what happened with him. But again, this could be anything. This could be, it doesn't have to be a particularly super value or anything like that. It could be a text message from someone you trust. And then once you enter your credentials, your account could be compromised. And then finally, the call center phish. This is something where a pop-up will come up on your screen. You have to call the number, and when you call the number, they say you owe them €300 to fix your PC. This one is very prevalent at the moment. There's a YouTube series by a guy called Dan Browning, where he basically took down a full call center of basically scammers. So if you wanted to look at that, it's very interesting. And then just finally, an authority figure. So a big authority figure in Ireland obviously is revenue. So this one, for example, is a tax refund. But imagine if you got an email saying that you were about to be emergency taxed, or that there was something wrong with your tax credits and you weren't going to receive your wages. People would panic, and they might click the link, enter their credentials, and again, this is how people get compromised. So just more on that then, the psychology of phishing, essentially. So there's a guy called Daniel Kahneman, and he's an Israeli psychologist and economist, and he came up with this theory where there's two systems of thought. So the first system is kind of like really quick. It's like a snap, like really, really quick, effortless, unconscious. A good example would be if you went into a waiting office for a doctor or a dentist or something, you would just sit down in any seat, you wouldn't really think about it. And then system 2 would be like much more long form. So if you were choosing what car you were going to buy next or something like that, you might think about it for a couple of days or a couple of weeks. So the idea is that system 1 is the system that like attackers would be trying to exploit, essentially. They want you to make a quick decision. They don't want you to look at the email too much, and they want you to just click the link, download the attachment, etc. So then air-gun phishing. So for us specifically, our employees are our first line of defense. Always, they're the ones who are receiving the email. So internal training is very, very important. And then our antivirus is our last line of defense. So basically, we're trying to put as many things as possible in front of the employee before it even gets to them. And then the internal training is meant to kick in for when they actually do receive an email. And then if they, well, hopefully they don't, but if they do click the email, the antivirus is the very last line of defense. Tools generally used in the industry then would just be email filtering programs. So like FireEye, whatever version of this, Fortinet, whatever version of this, Cisco, there's multiple different companies that all have these different products. Protection inside email boxes. So Google would have their own version with Gmail, and Microsoft would have their own version like Outlook. Website filtering, so just blocking malicious websites and things like that. There's multiple appliances for this. Firewalls that I'm assuming a lot of companies have installed, well, I hope so. And then phishing simulation attacks. So this is run by the company itself. So it'll be run internally. So it'll be sent to all the employees, and if they end up clicking on the link, they'd receive more phishing training just to prevent it happening in the future for real. So then just finally moving on to...
James, you're just getting close to your time now.
Oh, sorry about that. I'll just run through this there quick. So the possible implications for the power industry. So in Ukraine in the 23rd of December in 2015, there was a massive power outage. There was a phishing email sent to these users, and then there was accounts compromised. They waited about 2 weeks, and they sat in the SCADA systems. They learned how the system worked. And then after that happened, they completely blacked out the whole district. There was about 250,000 people obviously lost power, and they disabled the voice over IP phones as well. So the blackout couldn't even be reported. And then I'll just go straight to conclusion due to time. And then so every sector is vulnerable. There's going to be a higher volume of data centers in Ireland. I think it was mentioned previously, it's a big ICT hub. So a lot of companies are relying on TSOs. So obviously there has to be a lot of investment. There has to be a bigger team essentially to protect the TSOs, to protect the DSOs. And again, there's literally no 100% guaranteed way to prevent phishing emails. It's virtually impossible to stop them all coming through. But yeah, we can basically try and work on it and make sure our employees are well trained. So thanks for listening. And if you have any questions, I'll try my best to answer.
Thanks very much, James. Yeah. Go to the judges again if any of you have any questions.
Hi, James. Just a kind of overall question, because great presentation, very tangible. I've sometimes heard people push back against the whole smart grid concept. Okay. And actually to say, yeah, there might be cost savings, and instead of having to put someone in a van to drive out and operate a switch or send someone to a substation, there's a cost saving in that. But as soon as any kind of gear like that is in any way connected to the internet, you know, that's an attack surface from a cybersecurity point of view. So just, do you have any thoughts on that?
Yeah. So one example that I didn't get to there was actually about the US. So they had a report in 2008 that wasn't published until I think it was 5 or 6 years later. Where they said that Russia actually hacked into some of their systems. So basically the way they did it was essentially the smaller grids, they compromised accounts there, and then they were slowly making their way higher and higher up the chain. So assumably they were going to get to something like maybe a nuclear power plant or something like a hydroelectric station where they could have just opened the dams. So again, yeah, it's a lot easier to have your systems connected. Obviously, like IoT is like just like, it makes things so much easier, but it does leave you, open to certain things. So like, again, it's just having your systems configured correctly and things like that. And again, with phishing emails specifically anyway, it's where the problem, it's not the systems. Computers don't really make mistakes that much. It's like we make the mistakes. So
yeah, no, it's a great answer. It's a great sort of topic that I mean, I'm reminded of like things like computer voting systems that you know, a lot of security experts say no, like a pen and paper is fine. You know what I mean? That's you know, the savings aren't worth it. And, you know, when you look at things like cryptocurrency, you know, usually Bitcoin keys or whatever are kept air gapped. You know, they're not anywhere near the internet. And I just think as an industry, maybe we need to have a better language for discussing, you know, that actually sometimes low tech might be better for certain critical things. So I thought it was a great presentation that it kind of brought those things to light. So thank you.
Just on some of the stuff you were saying there as well, I think a lot of the smart grids are trying to operate in kind of blockchain systems at the moment as well, just because it seems a lot more protected and the security behind it seems a lot better than just like a database in the air essentially. So yeah, I think companies like LO3 Energy and things like that now are looking into a lot of systems like that. And I think Dingle are having a big project, something along the smart grid lines at the moment. So hopefully something like blockchain is implemented in that as well.
Brilliant. Thanks a million, James. Yeah, great presentation. I think we might move on there. If that's okay.
Thanks so much.
Thanks a million. Thanks a million for that.
Thanks, James. Very interesting topic. We're going to move swiftly on. Thanks to all our presenters. Great presentations. I might ask the judges if they could finalize their scores and start tabulating the finalists or the winners. Our next presentation will be our second guest speaker of today. It will be Jason Noctor. So Jason, would you like to share your screen there and you can start talking about your experience with CIGRE and give everyone on the call a kind of an insight on the benefits of joining?
Yep, sure thing, Connor. So my screen is being shared there now. So hello everyone, and thanks for attending the event today. So my name is Jason Noctor. I'm the current chairperson of CIGRE Ireland NGN, and I'm just going to give you a quick little talk here today. Firstly, I'm going to introduce CIGRE Ireland NGN to you, what we're involved with, who we are, what we do. Then I'm going to talk about some of the previous or past events that we've organised. This is just to give everyone on the call today a flavour of kind of the type of outreach we're doing to get young engineers and young professionals working in this industry all connected. And then, kind of similar to Conor Egan, I'm going to just give a brief little discussion about my CIGRE journey so far. So just to introduce the team, I'm not going to go through everyone, but as you can see, we're a 12-person committee. We're made up of people representing UCD, ESB, AirGrid, and EPRI. We're always very welcoming of new people who'd like to get involved in the committee, especially maybe from other organisations apart from the four here. So if you're ever interested in getting involved, please let us know. And just to give a special word of thanks while we have an audience to everyone on the committee. There's been great work done by all so far this year, and especially in organising some of the online events that we've had to deal with COVID-19. So CIGRE Ireland NGN then was formed in 2018. As Conor mentioned in his presentation, it was formed kind of out of a meeting of some young industry professionals from Ireland at the Paris session that year. And it has since then has grown, and we now have a very steady, active membership base. Our most recent figures shows that there are 77 people registered as CIGRE NGN members and who we can connect to via our mailing list. And this actually represents a 36% increase from 2019. So far this year, we've had engagement with up to 93 individuals. So that's 93 different individuals who have attended some of our online events. And our goal is to convert that number into full NGN membership for 2021. In fact, we're actually planning on going a little bit further, and we set a target to have over 100 members for 2021. And this is to help, represent and also celebrate CIGRE's centenary year. CIGRE was initially formed in Paris in 1921. So it'd be great to have 100 members in our organization to help celebrate that. So in our kind of relatively short existence, we've had many major milestones. So the first milestone I'm going to talk you through is our quarterly newsletter. So this newsletter was first launched in December 2019. And the idea of the newsletter was just to provide all our members with a recap of all the activities CIGRE NGN have been involved with in the previous period, and also to tie in together some industry news and other things that might be of interest. So the first newsletter was in December of 19. We've since then published 2 additional newsletters for Q1 and Q2. And we're in the progress of finalizing our newsletter for Q3 of this year. As I said, the newsletter includes items on CIGRE news, information on upcoming events, and notably then we also include some short technical abstracts from young members. We're key believers that people should have the opportunity to develop both their technical presentation and also their technical writing skills. And we use the newsletter as a platform to allow people to present short technical pieces on work that they're doing, which then we can circulate among our peers. So in terms of previous events, I suppose we've had 4 notable events since our formation. The first was in October 2018. And this was actually our kickoff event, which was held in the AirGrid offices in Ballsbridge. The title of this event was Challenges and Renewable Integration in Ireland and Japan. And notably, it featured a visiting delegation from Japan who made presentations to us, and then an Irish contingent who relayed presentations back. Our next event then was in July 2019. And this was a HVDC workshop and visit to the EWIC facility in Portan in County Meath. This was a very notable event for us as it represented the first collaboration between CIGRE Ireland NGN and CIGRE NGN or CIGRE UK NGN. And in fact, 10 members of the CIGRE UK NGN actually travelled over for the event. Following that then in October 2019, we held the Young Members Showcase and Flexibility Workshop. The primary aim of this event was to select 2 young CIGRE Ireland NGN members to go forward and represent the organisation at the Paris session. So in total, I think we had 10 very interesting and very informative presentations, similar to the style we had here today. Eventually, 2 winners were chosen. And in the evening then, we had a flexibility workshop with a panel of industry experts. Our latest event then was actually another collaborative event with CIGRE UK NGN. The title of this event was Challenges and Future Optimization of Onshore and Offshore Wind in Ireland and the UK. Now, given the constraints put onto us by COVID-19, this is actually our first delve into the online world, and we held a workshop very similar to that today. It was all held through Zoom, and we actually had our highest attendance to date, with over 110 people registering and logging on to the event. So I just have a little bit more detail about what I consider to be our 2 most noteworthy events. The first was the EWIC tour. We had 30 people in attendance, which, as I said, included 10 people from the UK NGN. The morning part included a reception and HVDC workshop hosted by ESB. And then in the afternoon, we travelled to Portan in County Meath, where we went on the tour of the East-West Interconnector facility. And that was kindly hosted by both AirGrid and ABB. We then returned to Dublin city centre in the evening time, and we had a very enjoyable networking event with our colleagues from the UK. This was really good for networking, making professional contacts, and just discussing both the challenges and the advantages of being a young professional in the industry. The second event then was our recent online workshop, which we held in collaboration with the UK NGN. We had 4 presentations from academia and industry, with 2 of our colleagues representing Ireland. The event, similar to this event, it was shared via YouTube, and I think it really showed everyone's willingness and determination to overcome the challenges of COVID-19 in order to promote CIGRE in both countries. So that's kind of just a whistle-stop tour of what we've been involved in with CIGRE so far. But I'd like to just take it back and tell you how I got how I got involved in CIGRE. So I studied for a BSc in civil engineering from UCD, which I graduated for in 2015, and then went on and did an ME in engineering with business, also from UCD in 2017. That same September then, I began on the ESB Graduate Development Programme, and I was positioned as an overhead lines design engineer with engineering and within engineering and major projects. Quite shortly after joining ESB, I was working on a project, and my manager said to me, you know what, there's lots of interest in reading and background research that you're going to need to do on this project. You should become a member of CIGRE and you'll be able to access lots of papers. And I remember looking at my notes at the time, and I wrote it down exactly like what I have here, CIGRE. Obviously, I had never heard of the organization before. I then had to go to my manager and said, well, how do you actually spell CIGRE? So he told me. I did a bit of Googling around. I got around to filling in the application form, and from then I've never looked back. So one of the highlights of my CIGRE journey so far was having the opportunity to present at the Young Members Showcase in Paris in 2018. The title of my presentation was A Field Method for the Management of Overhead Line Vegetation Clearance Encroachments. This was a really fantastic experience, and as Connor mentioned, it's good for giving you a platform to get established within the power energy sector, get your name out there and really contribute to some of the technical aspects that are being worked on across the world. When you attend big conferences like this, you'll realize that a lot of countries and a lot of utilities and organizations all share similar challenges, and it's really good to have the opportunity to meet people from further afield. With CIGRE Ireland NGN then, I was part of the initial steering committee, which was formed in 2018, and my first role was as events lead. I'm now the current chairperson as of 2020, and I just said I'd note some of the benefits that I feel I've gained from being involved. So I've been able to develop a wide range of skills, such as organization skills, whether it's organizing an event or just scheduling meetings, time management skills, although I know we're after going a little bit over time today, so people might disagree with that. I've also really enhanced my communication skills through, working collaboratively with different organizations, with people from different companies, and also I've developed my leadership skills. I see CIGRE NGN as being an excellent opportunity for networking, both within Ireland and also internationally through working with our colleagues in the UK NGN and other organizations. I've also got to gather some very valuable committee experience by really being thrown in at the deep end and trying to fight my way through the waves. So I think that was very, very beneficial. And overall, I think it's great for career development, and having something like being involved with CIGRE is also very, very good for interview content. You'll always be able to answer a tricky question with something like that. Kind of continuing on then through my CIGRE journey, I'm now also part of a CIGRE working group, which is a group of people from different utilities around the world who come together to try and solve a common problem. So the working group I'm involved in is B273, which is a guide for the prevention of vegetation fires caused by overhead line systems. Specifically, I'm involved in the Vegetation Management Task Force, and I'm working with a number of individuals from California, from South Africa, and from Australia at the moment. Now, unfortunately, at the moment, all the meetings are being held via Zoom, but traditionally, working group involvement always represented a very good opportunity to travel, meet people from different organizations, and see how things are done otherwise. As I said, I'm the Irish representative with representatives from all over the world, and involvement in the working group really is a great opportunity to become a technical expert, to network, and also to make a valuable contribution to real world challenges. So with that then, I'm just going to say thank you to everybody involved today. I'd like to extend a special thank you to our 4 judges. We really value their time. A particular thank you to the 8 people who presented, and also to the other people who submitted abstracts for this event. Kind of similar to Instagram, if it wasn't for the presenters, we simply wouldn't have any content to present. I'd also like to extend a very special thanks to the committee who's done a Trojan of work, especially considering the challenges posed by COVID-19 to get this event up and running. And then finally, I'd like to say thank you to the audience and to everyone who has signed in today to view this presentation. So I'll hand you back to Conor Mulholland now. So thank you.
Thanks, Jason. Very good presentation. Good indication of the insights into how you can maximize your experience in the power system industry by joining CIGRE. I'd also, just before we get our results from our panel of judges, I'd like to thank the Irish National Committee for sponsoring today's prizes. The first place prize will be an Apple iPad, with the second prize being Apple AirPods. So a massive thank you to the Irish National Committee for sponsoring those prizes. So I might pass over to Robert Donaghy, who will announce today's winners.
Okay, so thanks very much, Conor. And just on behalf of the CIGRE Irish National Committee, I'd just like to thank the NGN for organising what is the latest in a series of successful events. And I think it's clear the NGN is going from strength to strength, and long may that continue. I think online events are going to be the way of the future, certainly for the foreseeable future. And we've seen that in the recent CIGRE e-session, which moved from being an event in the Palais des Congrès in Paris to an e-session, and it was run quite successfully. And we're all hoping that next year we'll be able to convene in Paris in person for what will be the CIGRE centenary in August 2021. But I think we would all say that there's a chance that will also go online as well. So look, I'd just like to again thank all the presenters. I think in every case, the standard of presentation was very high indeed, and the presentations were extremely informative and educational. And I'd also like to acknowledge how well the technology worked in this case. I've been at many events where, for one reason or another, the technology let everybody down. But I have to say, in this case, it worked absolutely seamlessly. So thank you to everyone for that. So I'm happy now to move on to the announce the result. And we've got 2 prizes, and in reverse order. In second place was Anjukan Kathir Gamanathan, if I've pronounced that correctly. So well done, Anjukan.
Congratulations.
And the winner was a well-deserving winner is James Marr. So very well done, James.
Congratulations.
Cheers. Thanks so much.
Congrats, James. Fair play. Great presentation.
Cheers. Thanks so much.
Thanks very much, Robert. I think that draws an end to our event. Again, congratulations to the winners and also to everyone who presented. It was a great event, very informative, and I hope everyone found it interesting. So again, thank you very much for joining the event, and hopefully we'll be in contact soon with each and every one of you. So thank you again, and see you all. Bye-bye. Thank you.
Thanks very much. Thank you.
Thanks. See you later.